Okay, so we will discuss the variable and the parameter and the optimizer of the PyTorch in this video. So the variable is actually implemented in the Torch auto grade module. This is the auto differentiation implementation inside the PyTorch framework. So we will discuss this later when we discuss when we using the D0 to implement how to implement a deep learning framework. So we will discuss the detail later, but what we should focus right now is that in this function there is a the function called variable. The variable will be able to convert any tensors into a variable in the deep learning framework. Okay, so the variable you can think about it as a placeholder for a value inside the deep learning training. It could be a constant or it could be a parameters. For each variable, in addition to the value itself, it can hold another value called grade, like this. Okay. So for in the neural network, there's two kind of a variable here. The first one is a constant, so it's just the some kind of the hyperparameters, so that we can set up it to be any value, but those value will not be changed during the training process. In this case, we should set the required grade as the false. So when the required grade set to be the false, this variable will not be defined, and the deep learning framework will not update the value when we in the training loop. So typically, for the parameters inside the model, we should set it to be true, so that the grade variable will be available, and when we call the backward, we will calculate the value of the grade according to the rules of the deep learning framework. Okay, so the the object returned by the variable functions is actually an object which can be used to construct the computational graph. The computational graph is something like this. Okay, so touch.sum and the x squared plus y. So this looks like a mathematical expression, but actually it is used to construct a compute graph, and this computational graph can be used to evaluate the function defined by the computational graph. Okay, so we will discuss the computational graph later, but for now you just need to know that we can the variable, the object returned by a variable can be computed as other variable in the Python. Okay, and the other object is called parameter. The parameter, there's nothing special for a parameter. The parameter is exactly the same as a variable, but the required grade is true by default. So for the variable, the required grade is false by default, so that we need to set it to be true if we want the a to be some parameter which can be changed in the training loop. Well, for that case, we had better use the parameter class directly. So by using the parameter class, it will create an variable. It will create an parameters, a variable whose required grade to be true. So typically we almost use the parameter everywhere. Okay. So in here, we define a module, and then we in the module we will create some parameters here, and then we'll define a for function which can be used to construct the computational graph by using the input variable here. Okay. We will go back to the training code later, but the only thing we need to know is that for the modules, we can using the parameters to get all parameter defines inside the module. Okay, so you can see that we assign the parameter to some variable inside the object by using this. Actually, when we assign the parameter to an attribute of the module itself, the module will recall that the x is actually pointing to a parameters, and the module will keep track of all parameter created within the within it, and if those parameter is assigned to some attribute of the modules, the module will recall that the x is contain parameters, and the net and the parameters function will actually return all the parameters which has been assigned to the attribute of the module. So that in this way we can get all the parameters by using the for loop. Okay, the next thing is the optimizer. Optimizer in the PyTorch, the optimizer will define the function using to update the parameters inside the models. And different optimizer will using different strategy to update the parameters in the model. And we will not discuss the details here, but the thing we need to know that in order to update the parameters, we need to have a optimizer, and there's a lot of the built-in optimizer inside the PyTorch framework. The torch.optin.sgt is actually define the stochastic gradient descent optimizer, and we have other advanced, for example, the Eden or Momentum. There's a lot of the optimizer being implemented inside the PyTorch framework. Typically, you don't need to implement your own optimizer, since most of the optimizer has been implemented already. And for the optimizer, we need to pass all parameters which need to be updated into it. So this is why we need to implement the parameters function in the model. Since this model will return all the parameter which is created as and assigned to some attribute of the modules. So the optimizer will get the list of all modules, and in addition to those parameters, it needs some other hyperparameters. Different optimizers require different parameters. For the subtracted gradient descent, he needs a parameter called LR. And actually, the LR will be available in most optimizer. Actually, it is almost in every optimizer available right now. So for the optimizer, there's two most important functions. The first one is the zero grade. It means that this will set the grade variable like this one here. You will set the grade variable to be 0 for every parameters in which has been passed to the SGD optimizer creator. So this function will actually set all parameters returned by this function to be 0. So that in the those backward function, this function is actually where the backpropagation is implemented. So it will go backward of the computational graph to update the grade GRAD variable of every parameters to be the gradient against the parameters. After we have the gradient for every parameters in the network, we can use in the optimizer that step to update the value of those parameters inside the model. So if you not understand what I'm talking about right now, it doesn't matter. We will go back to discuss this in the next lecture. Okay, so the last thing we will talk about in this video is the touch region module. Inside this module, you will define a lot of data set, and you will define some utility to implement the data augmentation for the data set, and you contain a lot of pre-trained models. So basically, the touch region is contain the data in the model for all computer vision tasks. And actually, we have a touch audio and a touch text as well for the audio data set and the text data set. Okay, so inside the touch region, we define a lot of data set. So the next thing we need to discuss, is the data set. So this is a function which is using to implement to get a data set from the touch region module. For example, if we want have a CIFAR10 dataset, we can just using the touch vision dataset.cifar10 to get this function will help us to grab the data from the of the data set and save it under the root the folder which is set up by the root attribute, root arguments of the CIFAR10 function. And inside here we can set the trend. So for some models, the training mode and the evaluation mode will has a little bit difference, so that we can set out the modules, the train or evaluate. So inside the data set, the import, the reading code, we can try to implement those difference by using this variable. And we have a download argument which is when you set out to be true, you will download the data set if it has not been downloaded into the folders, the specified folders. And we will have a transform function which will be used to transform the data after it is written. It is read from the file system. And inside the transform, we can do the data augmentation here to add some variant, produce a different version of the same sample. And we will have a data loader which can be using to load the data set. So we will not discuss this in detail right now. That will be the content of the next lecture.